Okay, fine. Welcome back, guys. So, space technology. Okay, so we started with space, and then I have told you about space crafts. Yes, examples: satellite, shuttle. So, what's the difference between satellite and shuttle? Satellite is associated with orbit, and shuttle is not associated with orbit. Okay, and then we have seen rocket, engine or motor. Okay, using this we'll launch two things. One is launch vehicles, second one is missiles. Okay, and then we have seen orbits. Yes, orbits: leo, meo, geo, heo. Leo means 50 to 2000 kilometers, and meo means okay, geo means here means outer orbit. Okay, and then on the other side we have seen polar, inclined or transitional, equ- equatorial. Okay, so polar is associated with leo, inclined is with meo, and this equatorial is with geo. And in the leo I have told you this remote sensing. Okay, remote sensing, earth observation, eos. Meo, gps. Okay, geo, insat or gsat. And then we have seen, I mean, this is conclusion, fine. And then we have seen launch vehicles. Launch vehicles, first generation slv, four stages, all four stages are solid. And then augmented slv, satellite launch vehicle, five stages, all the five stages are solids. And then we have seen pslv, four stages: solid, liquid, solid, liquid. And then GSLV Mark 1, 2, three stages: liquid, solid, cryogenic. And then we have seen GSLV Mark 3, again three stages, but this time capacity increased. Okay, now see what happens here is, let's say this is rocket, this is rocket. Here you will be having payloads, here you will be having payloads. Okay, let's see this pslv. So when I say pslv, okay, so this rocket will be something like this. Okay, and here you will be having two more things, here you will be having two more things. So these are for initial power generation. Once initial power is generated, these two will be separated and they'll fall down. Okay, now in pslv we have how many stages? Four stages. So liquid, solid, liquid. Okay, now what happens is, let's say this is earth. Okay, and we are trying to enter into this orbit. Okay, this orbit may be, let's say assume this is at 40 or else 36,000. Okay, example. Okay, now what generally scientists will do is, this 36,000 we have four stages, so they divide these things into four, 9,000. Okay, now the rocket launching vehicle will start from here. Okay, once after traveling to 9,000 kilometers, okay, the fuel inside here, this will be exhausted, which means completed. Now this will be separated. Okay, this will be separated and this will be blasted. this will be blasted in the space, which means this will not be any space debris anymore. Okay, so mainly you'll find the ash. This will be blasted there. Okay, now on one side the weight is also decreasing. Now this time the remaining fuel it can carry to long distance compared to this one, because before it used to be more mass, but now mass is also reduced. Okay, after reaching to a level of 9K. Okay, now we have only 3 stages. I mean, these two things are also gone. Now we have only 3 stages. Okay, now after traveling to 9K kilometers more, this will also completed. I mean, they'll design in that way. The fuel inside will be completed. Okay, now this will also be separated and this will also be blasted in the space, so that there will not be any space debris. Okay, now again they will travel 9K. Okay, now this will also be completed and this will also be blasted in the space. Now we are left with one more thing. Okay, now this at a higher speed, what it will do is it will inject the satellite. It will inject the satellite. It will inject the satellite and then it will be separated and it will be blasted again. It will be blasted again. Now we are left with only launch vehicle, the system and all, and the satellite. Now satellite will be separated from the launch vehicle and satellite will be installed here over the orbit. Now this launch vehicle has 3 options. One, it will be there in the space, first option. If this is the case, then it will be space debris. So generally people will not use this. Second one is this will also blast in the space, second option. Third option is it will come down to the earth and will reuse the launch vehicle, and this technology is called as reusable launch vehicle, RLV technology, and recently Elon Musk has done this experiment and he has succeeded. So this is also your current affairs. Understood? Yes. So all these points, okay, these stages will be separated from the rocket in between. Okay, end of the day, only the launch vehicle will enter into the orbit. There in the orbit, it will release the satellite. Now launch vehicle has 3 options. Okay, so one is it will there in the orbit. Okay, so obviously this will be a space debris for us. So this option nobody will use. Second one is they'll make the launch vehicle blast. Second option. Third option is they'll get the launch vehicle back to the Earth's surface again. If this is done, then this is called as RLV. India is also tested this RLV technology as an experimental technology in 2018, it seems. Okay. Later, completely successfully experimented by this Elon Musk SpaceX company recently. When 2024 November, it seems. November 2024. Yes. So this is RLV technology. Okay. So for your understanding, I'm telling you. Anyways, in the current affairs point of view, I'll cover this again. Okay. So that is this only. Fine. Understood this one? Clear? Yes. Okay. Now people are asking me this to explain this balloon again. See, generally what happens is if you have filled a balloon or anything for the purpose. See, I mean these days this bottle video is quite popular in YouTube. What people are doing is they are filling air in the bottle. Yes, air in the bottle, and they are fixing the cap. And from the outside, they are giving warm temperature. They are heating the bottle. All of a sudden, they are opening the bottle cap. Okay, immediately what's happening is the inside the air pressure is more. So obviously, it is coming at a greater speed. It is coming at a greater speed to the Earth's surface. Which one? The air which is inside. Okay. Now Newton third law will apply. Once the air comes at a greater speed, in the same speed, the bottle will travel into the atmosphere. So the same experiment is nothing but this turbojet, ramjet, scramjet. Okay, but the speeds are different. Okay. Now new topic. New topic. Space missions. Space mission. Okay. Before that, write down an agency name. Write down United Nations. United Nations Office for Office for Outer Space Affairs. United Nations Office for Outer Space Affairs. United Nations Office for Outer Space Affairs. United Nations Office for Outer Space Affairs. Wait. United Nations Office for Outer Space Outer Space Affairs. Okay. United Nations Office for Outer Space Affairs. Okay. Generally, everybody is launching the satellites, vehicles. Okay. There are high chances that sometimes when we are launching, this mission may get failed and this will enter into the other territory and this may cause a damage to the other territory, other sovereign territory. Yes. So in that case, what happens is if there are any disputes, the disputes will be solved in this UNOOSA, United Nations Office for Outer Space Affairs. Okay. So this will suggest every country to frame a space laws. To frame a space laws. This will suggest every country to frame a space laws. Just like we are framing laws for CRPC, IPC, citizenship. Just like that, it is asking each and every country to frame space laws. But the thing here is, still now no country has done the came up with space laws. Only US is the only country it has came up with space laws. Remaining India is working on it. Australia, Canada, Europe, they are working on it. Okay. But the thing here is, whenever this is coming into your paper, okay, this is an agency. What it will do? It will listen to the space affairs. Okay. So let's say we are trying to launch a launch vehicle. Okay. This has become an accident and it has went to Pakistan. Okay. And there it killed 4-5 persons. Okay. This is not intentionally done, right? So in these cases, the negotiations will be done here. Okay. See, we haven't done intentionally. Okay. It was happened. So we are ready to pay the compensation. That compensation amount will be decided with this United Nations Office for Outer Space Affairs. Okay. And we'll pay that office compensation. Okay. For that purpose, there is an organization set up. That organization name is nothing but this UNOOSA. Okay. Nothing else from this, because this everyone is taking on a lighter mode. Okay. It has suggested each and every country to frame the spaceless, but nobody implemented, which means nobody is taking this organization on a serious note. So that's the reason there are very few chances that questions can be asked from this organization, but still we need to have an idea. Okay. Next. Keep a heading. Bharat Space Missions. Bharat Space Missions. Bharat Space Missions. Okay. So this will read in two sections. One is till now what are the missions which we have sent? Okay, the successful missions we'll learn first, and then what are the future missions that we are going to take. Okay, so keep a heading as successful space missions. Successful space missions. Successful space missions. Successful space missions. Okay, first one. Chandrayaan 1. Chandrayaan 1. Chandrayaan 1. Okay. See, listen to the story first. This is Earth, and this is the 36,000 kilometers, which means orbit, gravity. And this is Moon, and this is Moon's gravity. Okay. So whenever we are launching a satellite, we'll have 4 important dates. How many? 4 important days. When it was started. So from the Earth, when it was started. So this will be the first important date. Okay. For exams, this is the only important date. But for ISRO and all, these 4 dates are important for them. Okay. Second date is when it is crossing the Earth's gravity. Whenever it is entering from the inner orbit to outer orbit, that is also an important date for ISRO. Okay. And third important date is when it is entering into the Moon's orbit. Okay. And the fourth important date is, okay, so we'll decide a point, right? Okay, we'll decide a point. At that point, at that orbit, we need to inject the satellite. Yes. So, example, in Chandrayaan 1, we have decided this point is 100 kilometers from the Moon surface, which means, see, in the Earth also, polar orbit means 50 to 2000. So 100 kilometers from the Moon surface means obviously it is polar Moon orbit. So we have decided polar Moon orbit, and there the satellite will go and it will rotate around the Moon surface. Okay, see, I have already told you polar satellite. Okay, first it will rotate like this. Meanwhile, the Moon will rotate. It will rotate like this. Meanwhile, the Moon will rotate again. It will rotate like this. So this will happen, and it will scan the entire Moon. Okay, so our purpose is polar satellite. Okay, we haven't sent any geostationary satellites here. Instead, what we have said, polar satellites, remote sensing satellites, Earth observation satellites. We are sending to Moon, so we'll call this as Moon observation satellites. Okay, so in Chandrayaan 1, what we have sent? Remote sensing satellites to observe the Moon surface. Simple, to observe the Moon surface. So what happens is, I have told you 4 dates. Okay, in that, see, we started with, see, this date you need to remember, 22nd October 2008. Okay, and it has reached the Moon surface on 5th November 2008, and it has reached the orbit. It was injected into the orbit on 12th November 2008, which means how many days it took? 20 days. How many days? 20 days. So it started on 22nd October 2008 here. Okay, it has reached the Moon orbit on 5th November 2008, and from then it was injected into the 100 kilometers orbit from the Moon surface on 12th November 2008. Okay, so first thing you need to remember is 22nd October 2008. Second fact is, from where we'll be launching all these vehicles? Satish Dhawan Space Center. Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. Okay. So which vehicle we have used here? PSLV C11. Okay. Launch weight, launch mass 1380 kgs. Okay. And expenditure is cost which is associated is 380 crores. 380 crores. Okay. And the total payloads we have used here is 11 payloads. Okay. And 20 countries worked together. 20 nations helped us in launching the Chandrayaan 1. Okay. One is European nations, which has 17 countries at that time. So they have helped us. And then Bulgaria and USA's NASA helped us. And other one is India. So 17, 18, 19, 20. So 20 nations work together to launch this Chandrayaan 1 into the space. Okay. Now, last fact that you need to remember is lifespan. What is the lifespan? 2 years. Okay. And write down only 312 days it worked. It worked only for 312 days. So all these countries, they expected that the lifespan will be minimum 2 years. But the thing here is it has worked only for 312. Okay. So these are the facts that you need to remember. So now quite easy for you. Yes. So without looking at the board also we can say 22nd October 2008. Okay. So from Satish Dhawan Space Center. Okay. And the vehicle which we have used is PSLV C11. Okay. And then this maximum weight, the weight which is carrying is 1380 and the budget is 380 and the payloads we have used is 11. Okay. And the nations work together are 20. European nations 17, Bulgaria, and then NASA, and then India. So total 20 countries, and the expected lifespan is 2 years. But it has worked only for 312 years. Okay. So these are the facts that will be asked in the exam. Okay. So 4 important dates. And see, this has entered into polar moon orbit. Okay. That's the reason in Chandrayaan 1 we have used only orbiter. In Chandrayaan 2, we tried using lander and rover. See, simple. See, this is moon. Okay. And this is moon's orbit. If we are sending any satellite or any spacecraft, okay, this spacecraft, if it is rotating around the moon, then we'll call it as orbiter. Okay. If satellite, okay, spacecraft, if it is coming down onto the moon surface, and make landing here, then we'll call this as lander. If something we are sending on the moon surface and this something is moving on the moon surface, okay, just like, I mean, let's say it is a robot, it has wheels just like your cars. Okay, it has wheels and it is moving on the moon surface, then it is called as rover. So in Chandrayaan 1 we have used only orbiter. Okay, but out of orbiter also, how many payloads we have sent? 11. 10 payloads we have installed in the orbiter, and one payload what we have done is we have tried launching on the moon surface. Okay, we have done an experiment. So initially in the Chandrayaan 1 only we have done the experiment for Chandrayaan 2. Okay, later after 2019, in 2019 we have redone the experiment again, but in 2008 itself we have done the experiment of launching a spacecraft on the surface of the moon. Okay, so at that time it was successful. Later in 2019 we failed. Okay, why? I'll tell you the reasons again here. Okay, now in Chandrayaan 3 we have used all the three things and all the three things are successful. In the Chandrayaan 1, this we have launched 90 to 95% successful. Okay, and in Chandrayaan 2 we have launched all the three. This is 100% successful and these two are failed. And in Chandrayaan 3 we have launched all the three, sorry, two. Orbiter we have took the help of only this one, so everything is 100% successful here. Yes, understood the terminology? Now with this understanding, okay, write down these facts. See, when I say payloads are 11, in that launching vehicle, we have used 11 instruments. Okay, you name it, cameras, sensors, okay, all these things, okay. All together, we have used 11 instruments. 11 instruments, out of 11, one is for experimentation purpose as a lander. Even for the facts also, you need to remember it like a story. Then only you can remember the facts. Okay, so try remembering like this. Okay, trust me, you will never forget the facts. And this Chandrayaan 2 also 22nd only, but that time 22nd July 2019. Okay, Chandrayaan 2. Chandrayaan 1 is 22nd October 2008. In your current affairs also, what you will read? These things only. Yes. Whenever we are sending a missile, what is the name of the launching vehicle? Generally, people will ask you. PSLV C-11. From where it is launched? Satish Dhawan Space Center. And then on which day? 22nd October. What is the weight? 1380. What is the amount? 380 crores. Payloads 11. And then 20 nations work together. Lifespan 2 years. These are the facts which you will learn in current affairs. Nothing else. And the purpose is clear. We are using polar satellite. So obviously it is to map the moon surface. Yes. If this is on the earth, then they would have given the name called Cartosat. Okay. Cartosat. I have told you while discussing this remote sensing. Yes. Cartosat means urban mapping. Okay. Cartosat means cartography means study of maps. Study of maps. Okay. So study of maps. So whenever you are sending a satellite for the mapping purpose, for the mapping purpose, then it is called as cartography. And the satellite which is associated with the cartography is nothing but Cartosat. And if you are sending it to learn about the ocean waves and movements, then it is called as oceanosat. If you are sending it to find the resources, then it is called as resources sat. Okay, so based on the purpose, we'll give the name. Okay, so here basic purpose is to map the moon and to find the resources. Done? Yes. Now, this you want to write down? No? Okay. No need, right? Anyways, again in Chandrayaan 3, we will discuss all these things. Okay. So, see, lifespan is 2 years, and it worked for 312 days. In 312 days, it has took 80,000 photographs. 80,000 photographs, and it has done almost 50% of moon's mapping. Moon's mapping. And it has find 90% of resources of the moon surface. 90% resources of moon surface. 90% resources of moon surface. See, mission's objective is 100% resources finding and 50% moons mapping. Sorry, 100% moons mapping. So here they have expected it for 2 years, but it has done in, it starts for 312 days. Okay. So if somebody asks you whether this mission is successful or not, to an extent it is successful only, because almost here 50% task is done, and here 50% task is done. So close to 70-80% task is done. So to an extent, this is successful only. At least as Indians, we need to recognize this is a successful machine. Successful mission. Okay. Done? Note it down? Yes. So keep a heading as achievements. 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 We have become fifth country. We have become fifth country to enter into the we have become fifth country to enter into the moon's orbit. Okay. After USA, Russia, Japan, European Union, we have become fifth country. Okay. And you know what? Before that, people used to make assumptions saying, I mean, there is water on moon surface. Okay. But this Chandrayaan 1, it confirmed that there is water on the moon surface. So second achievement is confirmation of water on moon surface. Water on moon surface. Okay. And it has confirmed this moon surface has iron minerals. Iron minerals. Iron minerals. And specifically pyroxene. Specifically pyroxene. Okay, a type of iron mineral, nothing else. Okay. Next, before people have already they have sent the satellites to the moon orbit. USA, Russia, Japan, and European Union. Okay, these people told me that the moon surface is having only craters. Craters means I have already told you Earth has two advantages. One is moon, second one is poles. Okay, these two things are saving us from asteroids. So whenever asteroid hits a surface, okay, there a crater will be formed. Okay, which means a kind of hole. Okay, so all these countries before they went and they have observed the moon surface from 200 kilometers. And what we have done? We have moved a bit closer to 100 kilometers and we have observed from the 100 kilometers. And we have told to the world that Moon has craters as well as peaks, some mountains as well. Okay, craters plus peaks. Craters plus peaks. Craters plus peaks. Okay. And the fifth achievement is, I have already told you, we have taken pictures from 100 kilometers. Before everybody, they had taken pictures from 200 kilometers. Yes. Pictures from 100 kilometers height. 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 Okay, so this is all about Chandrayaan 1. Okay, so simple. Chandrayaan 1, we started on 22nd October 2008. Okay, from Satish Dhawan Space Center. Okay, using PSLV C11. Weight 1380. And we spent 380 crores. Payloads 11, 10 for actual use, 1 for experimental purpose. And then 20 countries they came together to work on this project. So 17 from European nations, Bulgaria, and then India, USA. Okay, and then the lifespan is 2 years, and it worked only for 312 days. Okay, even after working for 312 days, it has taken 8,000 pictures, 80,000 pictures, and out of 80,000 pictures, it has done 50% of the moon's mapping, and 90% of the resources it has found out. Achievements: we are the fifth country to insert our satellite in the moon's orbit after USA, Russia, Japan, and European nations Union. And then second achievement is, before that people used to think about, I mean, whether there is a water on moon surface or not. I mean, they used to be in a chaos mode. They know water is there for sure, but on a chaos mode. No confirmation of water. So this Chandrayaan 1, it has confirmed that there are water molecules on the moon surface. Okay. And minerals also it has found out. Iron minerals, particular type is pyroxene. And then it, I mean, before people used to say that this moon has only craters. Okay, I mean, see, even in whenever we are watching the moon, generally what we'll see? We'll see craters only. From Earth's surface also, craters are visible. The dark spots. Okay, those dark spots are nothing but craters. So people used to say moon surface is having only craters. But this Chandrayaan 1 told to the world that moon surface has craters as well as peaks. Okay, and we have observed this moon surface from the 100 kilometers for the first time. Before that, everybody observed from the 200 kilometers. Okay, so these are the achievements of Chandrayaan 1. Okay, now Mission Mangal, second one, Mangalyaan. Mangalyaan 1. Mangalyaan 1. Why Mangalyaan 1? Soon we are going to launch Mangalyaan 2. That's the reason this is Mangalyaan 1. Okay, right on. This is also called as MOM. 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 In bracket, write down Mars Orbiter Mission. So here also we are sending only orbiter, not the lander, not the rover, only orbiter. Okay, done. Now see Mars Orbiter mission. Okay, so obviously whenever we are seeing this, first we'll see on what day we started. Yes, on 5th of November 2013. 5th of November 2013. Okay, from where? Satish Dhawan Space Center. Satish Dhawan Space Center. Okay, using vehicle, obviously I have already told you PSLV. Okay, PSLV. C25. PSLV C25. PSLV C25. And the launch weight 1350. Launch weight is, see here I am writing it as launch weight, but actually it is mass. Okay, why I am writing it as weight is because in current affairs you will find it as weight only. Okay, but in the space generally we'll use mass because weight will decrease in the space because weight is associated with gravity. Okay, now it has reached there in September 2014, which means it took 9 months. How many months? 9 months. And it has entered a Martian transfer orbit. Before in the Chandrayaan 1, we have seen just moon's polar orbit. Okay, so that is moon's polar orbit, which means in the polar region it is rotating. But here we have given a name called Martian transfer orbit. Martian transfer orbit. Okay, done. Lifespan. Lifespan 3 years. Lifespan 3 years. And payloads we have used is 6. Payloads we have used is 6. Okay, and we are the 4th country to achieve this achievement. We are the 4th country after obviously US, Russia, and European Union. US, Russia, and European Union. And we are the only country we got successful in the first attempt. Only country successful in the first attempt. We are the only country successful in the first attempt. Okay, so this is all about Mangalyaan. Okay, so 5th November 2013, 5th November 2013, and it has reached in September 2014, which means it has took 9 months, and the orbit is called as Martian transfer orbit. Okay, and the vehicle which we have used is C25 PSLV, obviously PSLV and C25. Launch weight is 1350. Okay, and from Satish Dhawan Space Center, payloads we have used very less here, 6 only. Lifespan is expected 3 years, and it has achieved more than that. Okay, so always lifespan will take minimum. Okay, so it will work minimum 3 years. So it worked minimum 3 years, and it has extended also. Okay, and we are the 4th country to achieve this achievement. Okay, and we are the only country we have succeeded in first attempt. Okay, and this USA mission also will read. Okay, so everybody is trying to reach this Mars because see, on the moon surface generally the temperature is 80, 85, 90 degrees. Okay, so in South India the temperature in summers is merely around 43. Okay, so we are unable to live in 43 degrees Celsius. How come we are living? We are able to try in this moon surface because moon surface temperature is 80 degrees Celsius during the daytime. So it is not possible. Okay, even we have to make this possible, then what we have to do is we have to construct buildings wherein we have to control the temperature inside the buildings. Okay, so people are looking for this Mars planet. Mars is close to the Earth's surface, and the atmosphere temperature of Mars is close to 14 degrees, 13 degrees. Okay, so this is helpful for us to live over there. That's the reason people are launching their experiments towards Mars instead of moon. Okay, so this is the reason. And see what I have told you, the mission name is Martian. Martian means Mars transfer orbit. Okay, so transfer orbit, I mean there is a story behind this, and this story they have clearly shown you in this Mission Mangalyaan movie. Okay, so as you haven't seen this movie, let me explain. So what happens here is generally the budget allocated for this team is quite less. So with this budget, initially they can't get the launching vehicle itself, because to reach the Mars, which means outer orbit, generally people will assume like they need GSLV. They need GSLV. So GSLV is associated with more cost. Okay. So the budget they have given is initially 150 or 200 crores only. Later some mission got cancelled and that mission's budget is allocated to them, and they have increased the budget to 380 crores. Okay. Now what happened is they don't have a budget. So initially they'll cancel the mission. They'll cancel the mission. Meanwhile, anyways, the mission is cancelled. So Vidya Balan, she'll get back to the home and she'll help in the cooking. Okay. So meanwhile, her maid is cooking. Okay, doing the these recipes, puri. Okay, while doing the puri, what happens is all of a sudden the LPG is done. The gas is over. Now, before the gas is over, it will give you some signals. Okay, there is a kind of blue flame will come. Okay, once the blue flame is coming, which means the gas is about to end. And here in this Vidya Balan house, there is no extra spare gas. So what Vidya Balan will do is, she is a ISRO scientist. Okay, so she'll use her knowledge in making puri. What she'll do is, initially she'll give temperature to the oil. Once the oil gets required temperature, she'll off the flame. Okay, now with this temperature, she'll cook 10 puris, and then she'll give the flame again. Now with this temperature again, she'll cook 10 more puris, and then she'll stop. Again she'll give the flame. Again with the same flame. Okay, once it reaches the temperature, she'll cook 10 more puris. Okay, so once she has done something like this, she'll get an idea, and she'll straightly go away to Akshay Kumar, and she'll share her idea to Akshay Kumar. And Akshay Kumar, immediately there is an important meeting which is happening in the ISRO. Akshay Kumar will jump into the meeting along with the gas stove, some puris, some oil, and one gas cylinder. Now he'll do the same experiment over there. He'll give flame, he'll increase the temperature, and then he'll turn off the flame. Once the temperature is gained, they'll cook 10 puris and they'll keep that out. Okay. Again, they'll give the flame, they'll cook 10 puris. So this concept, what they'll do is, see, this is Earth's surface. Okay, and this is moon. This is moon. This is Earth's orbit, and this is moon's orbit. Okay, now to reach the moon surface, before generally, I mean everybody, USA, Russia, European Union, Japan, everyone, they used to follow the path like this. They used to enter the moon surface and they used to inject into the orbit of their required target. Okay, but because of this Vidya Balan idea, I mean in general Vidya Balan, but the actual scientist is different. So what Vidya Balan has done is, initially while starting, what Vidya Balan has done is, see, I have already told you, we need energy just to install in the orbit. Once we install in the orbit, automatically in the orbit, it will rotate without the fuel. Remember? So here Vidya Balan, what it has done is, she gives some energy. Now it will enter into the orbit. Once after entering into the orbit, it will run into the orbit. It will run into the orbit. It will run into the orbit. Now to change the orbit, okay, once after reaching here, they'll give some more energy and it will change the orbit. Once after reaching here again, they'll give some more energy and they'll stop the engine. Okay, now this will change the orbit. Now after reaching this point, they'll give more energy at a time, and at that time they'll reach the moon orbit. Okay, now again same process. In the moon also, they'll stop the flame. Initially, they will rotate again the moon, around the moon. Okay, now they'll give some energy and they'll reach closer to moon, and they'll will give some more energy and they'll get closer to the moon. Okay, this technology they have used for Mars. Okay, so whenever this kind of technology you are using, then this orbit is called as transfer orbit. So slowly we are transferring the orbits by giving a little bit of energy. Okay, whenever we are using this technology, then we'll call this as transfer orbit. Here we are traveling towards Mars, so Martian, and we are using this technology, and this is called as transfer orbit. Okay, so this is the story. Okay, the story I have told you just to remember this name. Okay, and this is Martian transfer orbit. Okay, so one more time, quick revision. 5th November 2013, and it has reached on September 2014. Okay, so launched from Satish Dhawan Space Center. Launch vehicle PSLV C-25. That one is PSLV C-11. Okay, and launch weight is 1350. That is 1380. Okay, so and then lifespan is 3 years. It has performed more than 3 years. Okay, and then payloads we have used less, only 6. Okay, fourth country to reach this achievement. Before USA, Russia and European nations have already done this, and only country we have succeeded in the first attempt. So this is mission Mangalyaan. Okay, now today's task is go and find the movie and watch the movie. Okay, so remaining missions we'll do tomorrow. Fine. Chalo then, bye for today.